Hey, it's Mrs. Freeman. This is lesson 7.3. So we're at the last lesson in chapter 7. It's about measures of center. These are definitely things that you've seen before. So this might not be too bad for you, but we're just going to kind of refresh your memory a little bit. Go ahead and label your notes page and pause me if you need some more time. Here's what these measures of center are. They're mean, median, and mode. So these are your three vocab words for the day. Mean, median, and mode. The mean of a data set is the sum of the data divided by the number of data values. Okay, the median for a set with an odd number of values, the median is the middle value. For a set with an even number of values, the median is the mean of the two middle values. Okay, so that means if I've got 1, 2, 3, 4, 5, 6, 7 values, and they're listed from least to greatest, well, my median's just going to be this one right here in the middle, because I've got 3 on the left, 3 on the right. But if I had, let's say, 8 values, there wouldn't be a middle, because the middle would be right here, 4 on each side. So what I would have to do is add these two values together, again, listed from least to greatest, and then divide them by 2. So I'm taking the mean, which is this one, of the two middle values. And then the mode of a data set is the value or values that occurs the most often. So it is possible that you have no mode, because maybe you just have every value once. Then you're not going to have a mode. But let's say I have like 3, 4, 5, 5, 7, 10. That's my data set. My mode in this case would be 5, because it's the only number that appears twice. Okay, it's also possible that you can have more than one mode, because maybe my data set was 3, 4, 5, 5, 7, 10, 10. Okay, now I've got two numbers twice, so they're both my mode. I've got two modes. Example 1 says, the table shows the heights of several tomato plants in a garden. Then it says, use a graphing calculator. We're not going to use a graphing calculator. Find the mean and median of the data. So we are going to find it by hand. We're not going to use a graphing calculator. That's something you will start doing in Algebra 2. So to find the mean of this data, this kind of looks like an XY table, but notice how it's labeled over here. It's not an XY table. Each one of these values is a height of the plant in inches. So that's my data. Each one of these 10 boxes is a part of my data set. So to find the mean, my job is to add all of these together. So 65 plus 72 plus 67 plus 78 plus 81 plus 77 plus 21 plus 69 plus 76 plus 27. I'm going to grab my calculator here and add all those together. And I got 633. So hopefully that's what you got. I'm just going to check myself real quick. Yep, I got that twice, so I think we're in good shape. And then the definition of the mean said the sum of the data, which is what we just did, divided by the number of data values. So now I have to divide all of this by how many there are, and there are 10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm dividing this by 10. 633 divided by 10 would be 63.3. So my mean is 63.3. Another word for mean is average. Out of all these data combined, the mean is my average. All right, and then the median, let's go back and remember what that definition was. It was the middle value, okay? So the first thing I have to do is list these from least to greatest. I'm going to go ahead and do that. Looks like 21's the smallest, then 27, then 65, then 67, then 69, 72, then 76, 77, 78, and 81. Notice that most of these values are bigger than the mean. It's kind of interesting because usually the mean is going to be right around the middle, but all but 2 of these values are bigger than the mean. So these 2 are smaller and all the rest of these are bigger. But it's because this 21 and this 27, it threw off the rest of my data because they were so low. So because they were factored into the average, that's what made my average a little bit smaller. Okay, so for the mean of this, I'm going to find the middle 2 values. So I'm going to draw a line in the middle. This is 10 values. So there should be 5 on each side. 1, 2, 3, 4, 5. 10 on each, or 5 on each side, sorry. So because this is an even number, I don't have a number right in the middle. What I'm going to have to do is add these 2 numbers in the middle and find the average or the mean of them. So I'm adding them together and I'm dividing by how many there are, which is 2. So 69 plus 72 is 141. And then divided by 2 is 70.5. All right, then we talked about this word the other day called outlier. So mean, median, and mode, that is all something that you've seen before. Outlier, that might have been new to you this year. I think that maybe you've covered it in years past, but I'm not positive. So we're going to talk about it. An outlier, whenever we were looking at scatter plots, we had some scatter plot that was doing its thing, and then we had a point just off chilling by itself. That was called an outlier. So in a data value, it's going to be a data value that is much greater or much less than the other values. So when included in a data set, it can affect the mean, and we're going to look at that. Because if I were to find the mean of just these numbers right here, it'd be somewhere pretty close to the middle because they're all pretty close to each other. But if I added in this outlier, that would make my mean significantly go down. Okay, so let's look. This is a vocab word, so you should have defined it in your notes. Go ahead and pause if you need some more time to do that. Example 2 says, the table shows the heights of several Shetland ponies. A says to identify the outlier. Okay, so I've got 40, 38, 37, 38, 39, 37, 40, 28, 42, and 40. Notice these are all very close to the number 40, except for one. We got one down here in the 20s. So my outlier is 28, because it's the one off doing its own thing. Find the mean with and without that outlier. Okay, so I'm going to find the mean. First, I'll find it with the outlier. And to find the mean, we know we just add all these together. 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus another 38 plus 37 plus 28 plus 40, and then I divide that by how many there are. Again, there are 10 values. There's not always going to be 10. That's just a coincidence. And then if I add these together, I'm going to do it on my calculator here. Okay, I got 379. Let me double check. Yep, 379. All right, so 379 divided by 10 is going to be 37.9. All right, so my mean with my outlier with 28 is 37.9. Now let's find the mean without the number 28. And I'll do it in a different color here. So the mean without 28, and that's going to be 40 plus 37 plus 39 plus 40 plus 42 plus 38 plus 38 plus 37, skipping 28, plus 40. And then when I divide by how many there are, now there are only 9. If you divide by 10 again, it's going to give you a different answer. So we're dividing by how many there are, and since I took that one out, there's only 9. Okay, so when I add these together, I'm just going to take my 379 and subtract 28 from it because that's the only one I took out. You should get 351 when you add all these together. And 351 divided by 9 is 39. It says, describe how the outlier affects the mean. Well, my outlier was smaller than the rest of my data. So it made my mean smaller. And this one wasn't super significant. I mean, it only changed it by 1.1. But sometimes it can be much, much, much worse. Usually whenever statisticians are conducting studies and they're using data like this, if they have an outlier that's going to affect their data like that, they'll just throw it out. All right, last example. It says identify the outlier in the virtual reality headset prices. Alrighty, so I've got 1, 2, 3, 4, 5, 6, 7, 8 different virtual reality headsets. Looks like most of them cost right around $500, about $450 to $590 is my range, but then I have this one that is a lot smaller than all the rest of them, right? So that would definitely be my outlier. Headset A with $70. And I'm going to find the mean, median, and mode with and without the outlier. It says, which measure does the outlier affect the most? Okay, so to make this a little bit more organized, I'm going to make myself a table over here. Mean, median, and mode. And I'm going to find all those things with the outlier and without the outlier. And see which one it affects more. So for my mean here, we'll do the with column first. My mean with the outlier, I'm just going to add all these together and divide by how many there are. So 70 plus 450 plus 450 plus 480 plus 500 plus 540 plus 560. We're running out of room. Plus 590. And then I'm going to divide that by how many there are. There are 8. Okay, so using my calculator again, adding them all together. I got 3,640. And I need to divide that by 8. Again, I'm just going to check myself. Yep. And 3,640 divided by 8 is 455. So my mean with my outlier is 455. And that's dollars. Okay, my mean without my outlier, I'm just going to erase some stuff here. All I'm going to do is take out this 70. And I'm going to do the same thing. So I'm going to add all these together, divide by how many there are. Well, there's 8, but I'm taking 1 out. So now there's 7. Okay, so if I add all these together, or if I just take my 3640 and subtract 70 from it, because that's all I'm taking out, I'm going to get 3570 over 7. And then I'm going to divide that. And I'm going to get 510. So $510 is my average price without the outlier. Because if you look at my mean over here with the outlier, it's $455. Well, there's only 3 of these that are less than that. The other 5 are bigger than that. And this $70 is not represented by that mean at all. At all. It's paying $70 and paying $450 for something is a lot different. Okay, let's look at the median now. So that was my middle value. So what I'm going to do is list these from least to greatest. They're actually already listed from least to greatest in that table. 70, 450, 450, 480, 500, 540, 560, 590. And since it's my middle value and I have an even number, I have 8 things, I'm going to divide this in half, where I have 4 on each side. And I'm going to have to find the mean of these 2 values to get my median. So 480 plus 500, and I'm going to divide that by 2 because there are 2 of them. And that will give me 490. All right, and then my median without the outlier, getting my eraser here again. I'll just write those again. Okay, so I want to take out the outlier, which is 70. I'm erasing things. And now I have an odd number of values. I have 7 values. So now I can find a middle value. And it's going to be this one right here. There's 3 to the left, there's 3 to the right. So my middle value is my median. All right, the mode is the value that occurs the most often. So for the mode, I can just look up here at the table. Okay, I've only got 70 once. I've got 450 twice, 480 once, 500 once, 540 once, 560 once, 590 once. So my mode is the number that occurs most often. It's going to be 450 because it's the only one that occurs twice. If I take out this outlier here, it's still the only one that occurs twice, so the mode actually doesn't change. So the last part of my question, it says, which measure does the outlier affect the most? Let's look. My mode ended up being exactly the same, okay? My median only went up by 10, but my mean went up by 55. Okay, so the outlier affected my mean the most. And that's usually going to be the case. Alright, so hopefully this wasn't too bad for you. Like I said, you've done mean, median, and mode before. You've just never looked and seen how an outlier affected those things. So that is the new part that you're learning in 8th grade. Go ahead and try out your big ideas and let me know if I can help you at all. Have a great day.